Hello, and welcome to a video about math for graphics. In this video, we will see multiple coordinate systems. We will look at the problem of formulating the equations for a rotation in the format as follows. X rotated equals rotation times x original. We did the same in the previous video. We just needed to graph, map, project, and solve. In the previous video, we did all the work in a single coordinate system, the global coordinate system. In this version, we're going to use two coordinate systems. The solution steps were graphing the problem, further mapping the geometry with additional projection lines, calculating angles and lengths using trigonometry, namely SOHCAHTOA, sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and tan equals opposite over adjacent. And then finally developing geometry equations and solving. With this alternate method of calculating the rotation of a point, we rotate the origin and calculate the distance from the rotated origin. You will see you get the same equations. It is confusing. You may find yourself turned around. You may wonder, rotate right or left? We will be rotating the axis one way, and that will rotate the point in the other direction. So if we rotate, the convention is for positive rotation to be counterclockwise. So if we want to rotate a point counterclockwise, we need to rotate the axis clockwise. So here's the diagram, and you'll see here the mention counterclockwise rotation of the axis produces clockwise rotation of the point. But the convention is to rotate counterclockwise, so we're going to do it the opposite direction. We want the equation to be, this one's backwards. They're using this convention, but we want to use the opposite direction convention because OpenGL, their rotation matrix has cos theta minus sine theta and then sine theta cos theta, and so we want to do the same. Begin. First, we'll go over the previous version. So here's a point on a plane in the axis in the xy axis, and so x equals r, which is the length from the origin, r cos a, or r for radius, I guess you could say, because we're going to be rotating it and it's going to make a curve, and the radius is not going to change with the rotation. Just the x and y's are going to change. So x equals r cos theta, y equals r sine theta. Just basic trig. SOHCAHTOA, x equals r equals cos a equals x over r, which is the opposite. Adjacent. Cos a is this adjacent xo over the r, and then y is the opposite. This is the y. So then we would add we added a second point, and we made another triangle, made another right angle triangle, and that's our rotated point, rotated by b degrees. And now we have two triangles. So we have x equals r cos a, y equals r sine a as before, and now for our rotated point, we have x prime for rotated, x rotated equals r cos a plus b, and then y prime r sine a plus b. And then we subbed in the trig identities for sums of angle sums, and we plugged those back into the equation, and we got our, well, here it is. So we got our matrix. So here we see, although over here on this link, they drew it the other way because they were doing different convention. Their convention was, their matrix is to rotate in the clockwise direction, and here we want to rotate in the counterclockwise direction. So instead of drawing it as they did, just made it a little different. So instead of rotating the plane in the counterclockwise direction, we rotate it in the clockwise direction. And so when you draw it out, uh, there's one more line here we added. So I'll just draw it out again so you can see how it's done. So first we draw the x and y, then a point, and then this point now, this projection down to the x-axis gives us our x value of that point, which we have, and then a projection out to the y-axis gives us the y value of that point. Now if we take a plane and we rotate that by some degrees, any arbitrary amount of degrees. Now we'll draw an arrow here to indicate the direction of rotation. So the direction is clockwise, which we'll see produces counterclockwise rotation of the point. So there's our angle A. Now we're going to make a projection from our rotated plane to the point, down to the x rotated. So this here is our x-axis, and this here is our rotated x-axis. So we're going to indicate that it's rotated by adding a prime to it, which is just convenient to type. You could put maybe a subscript, but this single quote is on the keyboard, and I don't have to do anything. It's easy. And y prime now, and y also. I'm going to mark those. Okay. So I'll take this line and I'll extend that. That's our y. So we have x over here. This is our x value here. And then this is going to be our x prime value. So over here, these x's, these ones, maybe I'll make them into gray. This x prime is not the same as this x. This x prime is just saying that this axis is x prime. This x prime is the value on the x-axis. So I think that's not complicated. Okay, and make another line to mark the y prime. Okay, so here's y prime. So we need to find y prime and x prime. That's the whole mission here. So with this projection, we have two triangles now, and it's going to make so the problem is very simple. It's just a matter of a little algebra geometry. So this is a right angle triangle. This is a right angle triangle. If this angle is A, then this one is going to be 90 minus A. We'll call it B, because it's a right angle triangle. So the other two, this is 90 degrees. Obviously, I'll just draw it. This one is 90 degrees. And this one is 90 degrees. And this is a straight line. This one here. And this is a straight line. So this B and this one will be B2. And this one, again, 90 minus B equals A. A plus B equals 90. and so these two equal 90. So we're starting solving things. We have two triangles, and we have their angles set. Now we can just use right angle triangle algebra to figure out all these pieces. So we have to find, let's label some hypotenuses. That's what I did. Okay, so I put H right here. These are arbitrary. You can name them what you want as long as you follow your own convention. So here I'm labeling this triangle as H because this is the triangle, right angle triangle, made on from this angle here. From it's gonna use this Y prime mostly. I mean, sorry, it's gonna use this Y mostly. So I put H, and then this one is mostly gonna use this X prime. So I'm putting H prime. So it's arbitrary. These aren't actual. It doesn't have to be that. I'm just marking it for convenience. And now looking at the diagram, we'll make our equations. But before that, we can just look right away. So we want to find this x, and this is the y. From here to here is the y. From here to here is the x. That's what we want to find. We have this x going from here to here, and we have this y going from here to here. So these are all the givens, and what we're trying to find is this x from here to here, and this y from here to here. So right away we can just make some basic right angle triangle equations. Cos A equals x prime over h prime. Sine A equals y prime minus h. So this is y prime. So let's color it. Also, I colored the lines so it's easier to explain. So I'm gonna put this one. Use the same colors. Red. Make that one red. So we have to find, this is a missing, we don't have that. This is something missing in our, missing link. It's something we have to find to be able to solve this problem. And we'll make this one, made it green I think, so make it green again. So I'm just marking these down so we see, okay, we gotta find this line. Once we find these two lines, we have all the pieces. Because those are with this you'll see in a minute if they're not already obvious. Okay, so let's forget about this one for a minute. Let's first go for cos x1. So x1, x prime, sorry, not x1, x prime, and put it beside. So let me rewrite it. X prime equals h prime cos A. So we see from that right angle triangle, this is the adjacent, this is the hypotenuse, adjacent over hypotenuse equals cos of A. And then that red line, just like that red line equals h1 sine A. In the same way. That's the sine of A equals opposite over hypotenuse. So we got that. Now in the other triangle, okay, so that red line plus this h is going to make our y prime. So let's red y prime is equal to h plus red. So we can write y prime is equal to h1. We can sub it in, sine A plus red. Now we need an equation for, oh sorry, this is an h1. Red is h prime, not h1. I keep doing that. Okay, h prime sine theta. Now y prime is this h length plus that line, that red line. And we have an equation for the red line. So we got h plus, and red is h prime sine a. Okay, so now we have to get h. So let's look at h. H is easy to get because we have our y. So we can say h is equal to cos of a is equal to y over h. So h cos a. So y over cos a. So that's basically cos a equals y over h. Rearranging, we get h equals y over h. Well, maybe I'll write it in 2 lines. Cos a equals adjacent, which is y, over hypotenuse. And hypotenuse then, move it on this side, close down here, and we got that. Okay, next. So now let's start subbing back in already. Let's see what we have missing. So y prime equals y over cos a and plus h prime sine a. So we need to sub in for h prime. And h prime is equal to x minus green. So from the diagram again we see x minus green minus this green line gives us h prime. So let's make that equation. Because when you're doing these subbing things, you can't use the same equation over and over again. It's not going to do anything if you're subbing equation into itself. So we have to say, okay, we subbed in this triangle, and we got that relation. Now we'll go to this triangle, get a relation, and sub them together, and then we can eliminate some variables. So for h prime, we're gonna put. Let's make a new equation. H prime is equal to x minus green. Now we need an equation for green. Green equals, let's do it again. So sine a equals green over h. So green equals h sine a. Okay, so we got h sine a for green. Now we can plug that back into h prime. So we'll sub that back in. So h prime equals x minus h sine a. Okay, now we can go back to our y equation. So y prime equals y over cos a plus x sine a minus h sine a sine a. Is that right? Something looks like I made a mistake. Y. Okay, so h prime equals x h. Yeah, I did make a where did I make a mistake? Okay, so y prime equals y cos a plus h, which is x sine a minus h sine a sine. It looks right then. I didn't make a mistake. I don't know. It looks weird to me. Okay, so that's y prime, and what's missing now is h. So we need something for h. That's a given. H equals y over cos theta. So y prime, so sub h equals y over cos, not theta a, sorry, y over cos a. So we go y prime equals y over cos a plus x sine a minus y sine a by cos a. Okay, and let's rearrange that a bit. Y prime equals x sine a plus, or I'm going to put that one first, plus y one minus sine a over cos a. So 1 minus sine a, now equation of a circle, 1 plus sine squared, 1 equals sine squared plus cos squared. It's just easier to type it twice than to put the superscript there. So that's all. So I make it. That's why it looks like that. Okay, so 1 minus sine squared equals cos and cos. So we'll sub that in. Y equals x sine a plus y cos a divided by cos a. So we get our final result. Y equals x sine a plus y cos a. And that's the same answer we got last time. Okay, now we can go to x. So x equals h prime cos a. Oops, that went huge. Okay. And for h prime, we sub in y over cos a. Sub h prime, this equation here, already just reread, h equals y over cos a. So x prime equals y over cos a h y. Oh no, we have to sub in h prime, sorry. H prime, where's our h prime equation? H prime equals x minus h prime equals we want to get it quickly in terms of x and y and the angle. Maybe this one, x h prime equals x minus h sine. Okay, we'll go with that one. And h equals y over cos a. Maybe there's a shorter way. Oh yeah, there's a shorter way. And h prime equals x prime, oh no, x minus green yeah, that is the one. So we'll sub this equation here. That's what we did last time. So we take that one, h sine a. So we sub that in. X prime equals x cos a minus h sine a cos a. And now for h, we sub in y over cos theta. H equals y over cos, sorry, not theta a. So x cos a minus y over, well, y sine a cos a divided by cos a. Put it at the end. Now we get x prime equals x cos A minus sine A. And there's our two equations. And then in matrix form, again, we get x prime, y prime, and equals, and so we got x here, we have cos A and sine A. Cos A minus sine A, and then the next one is sine A cos A, and then that equals to x and y, times x and y, sorry. It equals x prime, y prime. I'll put in some curly braces for marking vector, column vectors. This marks a column vector. In a lot of textbooks they use this for a column vector. So that's what we'll do here. So that's what we're doing here. Put in a square bracket for the 2 by 2 matrix.